Alright, let's look at the last three questions on the sequences and series review sheet. So number 9, they've told us that in a geometric sequence the second term is 15 while the fifth term is 1.875. Let's write down this information. They've said that the second term is 15 and the fifth term is 1.875. Alright, well in other words then, remember in a geometric sequence, in general we know that un is equal to u1 times r to the n minus 1, right? So that must mean then that u2 could be rewritten as u1 times r to the power of 1. And u5 could be written as u1 times r to the power of 4. So then we've now got two equations, there and there, with two unknown values in them. Okay, let's just get rid of those things. So 15 equals u1r, 1.875 equals u1r to the 4. Let's divide one term by the other. You're going to find it's always easier to put the bigger r on top. So I'm going to put 1.875 equals u1r to the 4, and we'll divide it by the other ones, 15, and this one was a u1 times r to the power of 1. The u1s will cancel, that's the beauty of this system. And you'll have r to the 4 over r to the 1, which equals r cubed. So let's see what 1.875 divided by 15 is. And we get 0.125. So we've discovered then that r cubed is equal to 0.125. That means that r is going to equal the cube root of 0.125. And the cube root we'll find in the math menu. Math cube root. Wow, weird glitch. I don't know if I can do anything about this, but we'll see. Where's my enter button? Cube root of, oh my gosh, I'm running blind here. No, and now I don't even know how to delete. Gosh, this is difficult. Second quit. So I want then, this is brutal. This cube root of, that's what I want to replace with a 0.125. And phew, there we go. I got an r value of 0.5, and that's my answer for part A, 0.5. I'm just going to reboot my calculator, which has annoyingly crashed. Is there anything I can do? No, let's just reboot it. Yes, I'm still here. Okay. Calculator's working again. Except that we've got this red screen. There we go. Alright, we're ready to move on to part B. Hence, find the first term of the sequence. So, if r is equal to 0.5, we can substitute that, say, into this equation, the one that said that 15 was equal to u1 times r, and our r we already figured out is 0.5. So then we must divide both sides by 0.5 to get u1 alone, and so u1 equals 15 over 0.5, and on the calculator we get 30 as the value of u1. And C, calculate the first term of the sequence that is less than 0.5. So we've got a sequence. I'm just going to put this into y equals. We've got a sequence whose first term is, we worked out, was 30. And it's always multiplying a common ratio of 0.5 raised to the power of x minus 1, like any other geometric sequence. So I'm going to now look at the table of values, and I want to find out when are we first less than 0.5. And I can see that that happens for the first time on row 7. So I'll just explain what I've done then. I first said that y1 was equal to my function of 30. It's my first term, r to the power of n minus 1, or x minus 1. And so now I've got my x and my y1. My row where it wasn't big enough, or sorry, where it was too big, and my row where it had finally gotten less than 0.5 at 0.46875, and therefore it will be the 7th term will be the first one that is less than 0.5. Question number 10. We've got this sequence of numbers. That's our first term u1, our second term u2, our third term u3. We know that the sum of the first 1 terms, which is a little bit of a strange thing, but yeah, the sum of the first term only is 5. Well, that must mean then, of course, that u1 is equal to 5. And then the sum of the first 2 terms is 12. So what's the second term? Well, if the sum of the first 2 terms is 12 and you figured out that the first term was 5, that must mean that the second term is 7. Now let's find the common difference. Well, if our first 2 terms are 5, 7, and so forth, our common difference can be found by doing 7 minus 5 equals 2. Therefore, D equals 2. And we need to find the sum of the first 4 terms. So we know that the sum for an arithmetic sequence is going to be n over 2 times 2u1 plus n minus 1d. So let's substitute what I know. I can see that I'm dealing with the first 4 terms, so 4 over 2. 2 times u1, which we can see up here, is 5. 4 minus 1 times the common difference of 2. Type this all into the calculator. So here we go. 4 divided by 2 times, open brackets, 2 times 5 plus 3 times 2, and we get an answer of 32. And you're done. Now this would actually be quite easy to work out in a different way, because you're looking at the sum of only 4 numbers. And if your first numbers are 5, 7, and your common difference is always 2, your next 2 numbers will be 9 and 11. So you could just add 5 plus 7 plus 9 plus 11, and that will also be a quicker way of getting to the answer of 32. And the last problem on this sheet. Each year a machine loses 15% of its value. So the machine loses 15% of its value. If you prefer, you can write it as 1 minus 15% like that. That would be okay. Alright. 1 year after it was bought, so it's already lost this 15% for 1 year, the machine was worth 5,100. So the initial amount that it was worth is let's call it the present value of the machine. And 1 year from now, the future value will be 5,100. There's 1 year from now. And the present value is only going to be worth 85% of what it was. So this means then that the present value is going to be equal to 5,100 divided by that 1 minus 0.15 or 0.85. And so what was the initial amount, the initial value of the machine before it lost the 15%? And we find out that it was initially $6,000. That makes sense, doesn't it? You expect the initial value to be higher, and then when it loses 15% of 6,000 after 1 year, it's now down to 5,100. Part B. Let's calculate the value of the machine 4 years after it was bought. So its initial value of 6,000 is now losing 15% for 4 years. So we got 6,000, which is multiplying 0.85 raised to the power of 4. And now the machine has gone down to the value of just 3,132.04. We must round financial problems like money to 2 decimal places. Or I suppose you could round it to the nearest dollar, which would be 3132, or you could even round it to 3 significant figures. But do not include the 7 and the 5 in your answer, because how could you have that many decimal places for cents? Part C. The owner of the machine says that he will keep the machine while its value is still greater than $2,000. Calculate the number of years the owner will keep the machine. Okay, so we're trying to find out then, when is the future value going to be less than $2,000? So we want our amount to be less than, so this amount is less than this. Oh, so sorry, I need to write that backwards, don't I? So, let's start again. I'm starting with a $6,000 machine. It's losing 15% every year, so that's multiply, so it's only got 85% of its former value. I want to know how many years will it be before we have it as a value of less than 2,000. So let's put this into the calculator. My left-hand side is 6,000 times 0.85 to the power of dear. Let's start again. 6,000 times 0.85 to the power of x. And when is it less than 2,000? Alright, let's look at a table. And I see that this occurs for the first time at row 7 is when finally we are at below 2,000. If you excuse me, I'm not going to copy the table for this problem. I've done it for several others already, and I want to move on to some of the IB questions in another video. So the number of years then is going to be 7 years, as seen by the table that you should copy.